right, absolute value. Solve this equation. What we first do is absolute value is equal to the square root of squared of whatever the value is, correct? Because you're squaring it, it equals that. Okay, I absolutely failed. But that was on the previous slide, but whatever.
JJ, why don't you go ahead and do it how you do it?
Well, how I would do it is, really with absolute value, all it is just plus or minus. And then you solve for that. So we get 3x minus 1, absolute value equals 6. That's the equation, correct? So then equals 3x minus 1 equals 6. Then you also write 3x minus 1 equals negative 6. Is that correct? All right, so then you just solve each equation. So 3x equals 7, and 3x equals negative 5. And then x equals over 3. Sorry, my handwriting's awful, but x equals 7 over 3, and x equals negative 5 over 3. Is that correct? All right, good.
JJ picked either 2 or 3.
2 or 3. All right, which one do you think is the worst one to look at? 2 or 3? 3? Oh, wait, 6.
We'll get to 6. You do 2 or 3.
All right, we'll just do 3 then. This one. All right, so what we first do is we need to get the absolute value equation alone by itself. Then we can do the plus or minus. So what we'll first do is we'll just do 3x plus 2 plus 1. Is this thing falling? Yes, it is. It's not my size, okay? So then that equals 5 and that. So. Yes, my handwriting is awful. I am aware of this fact. All right, so you end up getting absolute value 2x plus 1 is equal to 5 over 3. Correct? All right. I'm just going to remove all of that because I'm lazy. But, so then what you'd get is, okay, no, 3 there. Yep, all right. So then you get 2x plus 1 equals to 5 over 3, and 2x, that is horrible. No, I'm not even going to try that. That's 2x, okay? It doesn't look like it, but it is. It's equal to negative 5 over 3. Those are our 2 equations. Correct? You're learning. Good. So then we get 2x. Hey, at least you're actually learning. All right. All right. So then we divide by that. That equals. All right. So then when you just solve those 2 equations, you get x equals 1/3 and x equals negative 4 over 3.
All right, peeps, Ella here. Let's try this out. So we start with this equation. Now, in order to solve for absolute value, you must first get the absolute value alone by itself. So let's begin by adding 4 to each side, and we're left with negative absolute value of 5x plus 3. Sorry, subtract 4, excuse me. We're left with 1 over here, and then we times the entire thing by negative 1 because we want the absolute value to be positive, and we're left with 5x, excuse my handwriting, plus 3 is equal to negative 1. Now, peeps, we have a problem because you see this number right here is negative. And as you know, an absolute value equation will always end up being positive. Therefore, the answer to this is no solution or does not exist. Mic drop. Thank you.
Thank you, my students, for helping with those. But if you look at this, if you plug any value in for x, right? Let's say that value, after we simplify on the inside, comes out to be negative 100. What's the absolute value of negative 100? 100. What's the absolute value of negative 1? 1. What's the absolute value of negative pi? Pi. All our answers are coming out to be positive, therefore they can't be negative. So if you isolate the absolute value and that equation is equal to a negative, that just means the absolute value graph is above or below the x-axis and will never touch the x-axis. Because what we're trying to do here is find out where this thing equals 5. Well, it never will. Right? Okay. I want to go back a couple slides to this, right? And I wanted to start with this, but if I combine these two numbers, right, these are just like vertical shifts to this absolute value function. I'd have 0 equals, what is that, 3 plus 3 times the absolute value of x minus 2. Okay, and then I'd subtract 3. Okay, and then I go from there and I divide by, and look at that, I get another situation. What's the answer here? No solution, right? This absolute value has been isolated, it equals a negative number, therefore no solution. So be very careful. No solution. All right, let's skip ahead. Some of the formality stuff on properties of absolute values, they're pretty self-explanatory. You can look at those on your own time, ask me questions on that. I want to talk specifically about 5 and 6. Okay, number 2, okay, we'd subtract, all right, we get this, x plus 5 equals negative 2. The negatives, oh, it can equal a negative if they're both negative, therefore x plus 5 would equal 2. And then we could go ahead and go x plus 5 equals 2, and x plus 5 equals negative 2. All right, and then we'd work from there. So our solutions would be x equals negative 3 and x equals negative 7. Cool. So far, so good? All right, 5 and 6 have a couple tricks to them. Here are the tricks to 5 and 6. That wasn't intended to be like that, but it worked out. Okay, whatever comes out of here will be either positive or negative. So I'm going to write out the positive version of it, and I'm going to write out the negative version of it. Okay, now if I want to know where those are equal, I have to set it up all on one side, set it equal to 0, and factor. Oh, gross. All right, let's do it. So 0 equals x squared minus x minus 6. That's pretty easy to factor. That'd be x minus 3 and x plus 2. That gives me solutions of x equals 3 and x equals negative 2. Okay, the other side of things over here, I'll get 0 equals x squared plus x minus 6. All that's going to do is alternate and make this a positive 3 and a negative 2, which in this case gives us x equals negative 3 and positive 2. Now, only 2 of these are going to work. Only 2 of them are going to work, right? If you think about an absolute value function, it goes like this, right? Is it possible for that absolute value function to cross a quadratic more than 2 times? No, because think about the options, right? Okay, this would cross 0 times. This would cross, let's say, 1 time. This could cross up to 2 times. There's no way I could have a quadratic cross that more than 2 times, right? Yeah, JJ. Continue with figuring out which of these 2 are frauds. Well, what would I do? I'd plug them in. If you plug them in, you'll see that 3 works. Absolute value of 3 is 3, and 9 minus 6 is 3, so 3 works. Negative 2, I plug it in, I get a 2. But when I plug a negative 2 in for x squared, I get 4 minus 6, which is negative 2. So I get a 2 equals negative 2. It doesn't work. Plug in a negative 3, that one will work. Plug in a 2, and that one won't work. Okay, so be careful. Those are called, these 2 right here are called extraneous solutions. Extraneous solutions. All I'm going to do is get the absolute value alone. Okay. Absolute value of x minus 2 equals x minus 1. I'm going to go x minus 2 equals x minus 1, and the opposite of x minus 2 equals x minus 1. Okay, now over here you should see a problem immediately. What's going to happen when I try to move the x's to the other side? They're going to cancel, and I get negative 2 equals negative 1, which is not possible, right? So this one will have no solution. That one will have no solution. The other one will. I'll get negative x plus 2 equals x minus 1, and then I just solve. So on this side I'd get a 3, on this side I'd get a 2x, and so I see x equals 2/3. We can go back and check. Let's plug 2/3 in. 2/3 minus 2 would be negative 4/3, but the absolute value of negative 4/3 is 4/3. Oh, hold on. It's 3/2. Yep, that's goofy. Not bad. Should be 3/2. Thank you. Keep me honest. Once in a while I do that. I'm going to blame it on my children. Okay, so 3/2 minus 2 is negative 1/2. There we go. Absolute value of negative 1/2 is 1/2. 1/2 plus 1 is 3/2. Works. Okay. So be careful. Okay, graphing absolute values. What do you think is the most important point on an absolute value graph? Min or max, right? I call it the elbow. Right? Here's a boomerang. It's going to happen right there. Right? It's the change from where it has a negative slope to a positive slope, or the other way around. So you can identify where that is based on what horizontal transformations are taking place. So are there any horizontal transformations taking place in the first one? No. So it's going to be at 0. Okay, it's going to be at 0. And because it's positive on the outside, it'll have a slope of 1 going that direction and a slope of 1 going that direction. Okay, now that elbow is going to be shifted. It's going to be shifted how many units in number 2? 3 to the right. Right? So 1, 2, 3. Nothing has changed otherwise. So our sketch of our graph should look like that. Right? This is the point 3, 0. So far, so good. Where will the elbow of the graph be with relation to x on the third one? Has it shifted horizontally at all? Nope. So we'll be at 0, but it's also been shifted down 3 units. Therefore, for the third one, 1, 2, 3 in the negative direction with a slope of 1 and negative 1. Okay, so our last example for our graphing, I'm going to pause the video for a moment and then we'll get back to it. Okay, I've put number 4 into a form that will help us to identify the horizontal shift, and we already know the vertical shift. So we know the vertical shift is what? Yeah, 4, right? It's been shifted up 4. So I know that the elbow of this graph is going to be located at y equals 4. The horizontal shift, now that I've factored out that horizontal compression, right? That 3 gets factored out, leaving 1, turning 1 into 1/3. So this would be a shift which direction 1/3? Left, right? So it'd be shift to negative 1/3 to the left. This is the elbow of our graph. That's where it's going to change direction. Okay, but do we know if it's going to go up or down from there? Down because of the negative 2, right? Now, we don't know exactly where. Now, this is what you are probably going to be tempted to do on the test. He won't care. He doesn't care. I do care because those x-intercepts matter. I do care. Let's go back. So how do we identify that? Well, what I do is I set the whole thing equal to 0. And I find those 2 solutions of where it equals 0. Yeah.
Could you also just, like, you know,
Okay, guys, so what I did was I got the absolute value all alone. Now I'm going to solve for x. I'm going to subtract 1, divide by 3, and subtract 1, divide by 3, and I've found my 2 x-intercepts to be positive 1/3 and negative 1. Now that makes sense, right? because I got 7 seconds. This distance is 2/3 of a unit, and so is that distance. And this graph should be symmetrical.